Yeah, Assalamualaikum and very good morning to all of you. Welcome back to our class, BAA4273, the Earthquake and Wind Engineering. Today I will share with all of you about the seismic action on buildings. So we will discuss the part 1 today, which is about the nature of seismic forces. Okay, seismic force is acting on building in form of inertial force where it generated when the mass resist the acceleration of ground. Horizontal acceleration transfer up through the superstructure and generate the inertia throughout it. Okay, so this is the you can see this figure. This is the foundation. This is the column, and this is the beam. The ground acceleration move to the left, and the building, the higher part of the building still stay on the main position, on its original position, and then it will try to resist the motion, and it uh, vibrate back and forth, left and right. Okay, this is the difference between the gravity forces. Gravity forces acting vertically down to the earth, and the earthquake force is acting horizontally to the left or to the right. Okay, so this is the, for simplicity, as you can see, this is the masses, the inertia forces in the floors, column, and in the walls. And then we simplify, we assume that all the forces acting in at the center of masses for every story. And for further simplifications, we assume that the inertial forces acting externally. We assume that the forces acting on the joint of every story externally. Uh, pada hakikatnya dia bertindak adalah berdasarkan masses. Masses is the weight from the weight of the which come from the dead load, the safe weight of the structural elements from the imposed load, and it try to resist the horizontal movement of the ground, and it creates vibrations on the building back and forth. Okay, this is the wind forces. It act in form of pressure on the surface of the building, and this is the earthquake. It move it move with different directions. Okay, if the ground is moved to the left, so building will move to the right. It differ from the wind. If wind come from the from the left, and then the building also will follow the direction of the wind. Okay, this is the factors which affecting the severity of forces. As you can remember, according to Newton's law, the force is proportional to the weight. Okay, if you still can remember this equation, forces is equal to m times A, where m is the mass of the building or the weight, and A is the acceleration. So we must try to build as lightweight as practicable in order to reduce the forces, because it's proportional to the mass. So we can replace heavy masonry interior wall with the lighter material. The second one is the natural period of the building. Okay, as you can still remember our last lesson about the design response spectrum, we need the fundamental period of the building, which is the T1. Okay, the T1 depends on the weight, height, and the structural system. The third factor is the damping, where the damping caused by internal friction within building elements causes the amplitude of vibration to decay. It depends on the structural materials, okay, where the damping will reduce the movement and it will stop at certain period. And the ductility also affecting the severity of forces as well as the response spectrum. Okay, as I mentioned before, the fundamental period of vibrations can, okay, for buildings with height up to 40 meters, the value of T1 may be approximated by the following expressions. This is the equation 4.6 from Eurocode 8. You can find this equation in page 57, where T1 is equal to Ct times h to the power of 3/4, where Ct is the factor which is equal to 0.085 for moment resistant space steel frames, 0.075 for space concrete frame, and for eccentrically braced steel frames, and the value of Ct is equal to 0.05 for all other structures. And h is the height of the building in unit, the unit is meter, from the foundation or from the top of a rigid basement. Means h is the total height from a rigid foundation up to the top of the building. Okay, can you use your calculator to give me what is the fundamental period? Okay, fundamental period of vibration is a time taken for a building to complete one full cycle. Let's say you have a two-story building like this one. Okay, this is original conditions. Okay, and then if when the earthquake occur, it will cause the building vibrate back and forth, back and forth. Okay, so let's say it move, okay, vibrate to the right. So this is the displacement. Okay, and then it will, okay, first this is the original position. It will move, okay, it will sway to the right and then to the original position and then to the left, move to the left and then back to the original position. The time taken to complete one full cycle is known as the fundamental period of vibration. Or we can see like this one. So this is the T and this is the displacement. So let's say it move to the right, okay, let's say this is to the right, is up, and this to the left. But it move to the right, it go up to the maximum value of displacement or here, and then it go down back to original position, and then it move sway to the left up to maximum value here, and then it back to original position. So the time taken to complete one full cycle is known as fundamental period of vibration, or the T1. Okay, and then it will move again until it stop. Okay, as I mentioned to you about the damping earlier. So the higher value of damping will cause the building to stop from vibrate faster. Okay, let's say this is one cycle, and then it will move. It still move, but the displacement will become lower. Vibrate, move until it will stop. The displacement will become lower from by the time. Any question? Okay, good. So can you use your calculator and let me know what is the fundamental period of vibration for this two-story building if I give you the height of the building, let's say H1 is equal to 3.6 meter and H2 is equal to 3.5 meter. So please give me the fundamental period of vibration, and the building is moment resistant concrete space frame. Can you calculate for me? So the T1 is equal to CT times total H, power of 3 over 4. What is the value of CT for this case? Anybody?
0.085.
Okay, 0.085 is for steel frames, but I want the concrete frame.
Concrete.
Okay, sorry. Okay, good try, good try.
0.075.
Okay, 0.075. And then how about the H? What is the value of H?
7.1.
7.1.
Yes, 7.1 to the power 3 over 4. Because the H is the total, now you have to total up this one. 3.5 plus 3.6. Okay, so what is the value of T1?
0.326.
0.326 or 33 seconds. Okay, so means the time taken for this building to vibrate from the original position to the left, to the right, back to the zero position, then to the left, and then back to the original position again is 0.33 seconds. All right. So next, we will talk about the structural damage. It divided into two, which is the damage on structural damage system and the non-structural systems. Damage on structural systems will occur on the beam. Okay, like this one. Okay, this is you can see the crack occurred on the beam, and also on the column. This one. This is on the column, as well as the beam and column joint. Okay, this is the beam and column joint. This is typical damage occurred on the structure. Okay, especially near the joint. Okay, the region near the joint, we call it as, here we call it critical region. Okay, and damage on non-structural systems, you can see the damage will occur on the brick wall and partition, like this one. Like you can see the plaster of the brick wall spalling out of the from its position. Okay, this is the X crack pattern on the brick wall, and this is the ceiling. Okay, the ceiling will fall down. Okay, and this is according to Baraktar et al. 2003. Structural damages occurs on the RC buildings as a result of earthquake action, mostly associated with the following reasons. This is the reasons of the damage. Okay, you can find the detail, okay, by asking Mr. Google and Madam YouTube about this one. Okay, about all these reasons. Okay, which is the soft story failure mechanism, the weak column strong beam, short column effect, lack of transverse reinforcement in beams and columns, confinement reinforcement in beam column joint did not exist, existence of short lap splice and incorrect end hook angle, maybe also the poor quality of concrete, inadequate safe distance between buildings resulting in pounding effect. Okay, pounding effect means they say you have a building here, two-story building, and the position is too close. Okay, this is four-story building. Okay, one move, okay, sway to the right and one sway to the left, and it will collide with each other. Okay, we call it as pounding effect. Okay, and then the use of unribbed steel reinforcement, which cause weaker bond between concrete and steel, means the steel reinforcement is fully rounded and not have any. Okay, this is the ribbed reinforcement. Okay, wide spacing of triangle reinforcement leads to shear failure, means the spacing of a link is too wide. And buckling of longitudinal reinforcement and poor confinement of the concrete core. This is among the reasons of why RC buildings fail during the earthquake. Okay. Next, we'll discuss about the performance level. Performance level is to determine the status of the safety of building after the earthquake. It shows the performance of building against the earthquake. Okay, it is important to evaluate the structural performance after an earthquake so that the status of the building can be declared either safe for use, need to repair, or has to be demolished. There are three performance levels according to FEMA 356, which is immediate occupancy, life safety, and collapse prevention. All three performance levels can be measured based on the interstory drift ratio. Okay, so this is the performance levels, either the immediate occupancy, life safety, and the collapse preventions. And this is the type of damage, okay, either primary or secondary. What will happen for IO, LS, and the CP. Okay, and this is the indicator. If we look to the interstory drift ratio, so the immediate occupancy performance level, it will be 1% of transient of interstory drift ratio, 2% transient, 1% permanent for life safety performance level, and 4% transient or permanent for collapse prevention. So you can read what happened on the column, on the beam, and what happened on the concrete cover. Okay, so this one, okay, this is the immediate occupancy. The drift is limited to 1% only, and it is not permanent, means it will go back to the original positions. The building is safe for immediate occupancy. The risk of life-threatening injury very low, and some minor structural repairs may be appropriate. Means after the effect, means after the earthquake, it will we can declare that the building is safe and the resident can go back to the building. And then for life safety, it will be permanently drift of 2%. Okay, for reoccupancy, it will be safer to implement structural repair or install temporary bracing. Although repairing work is still possible, this option may not be practical due to economical reason. And then the last one is the collapse prevention, is the level where the interstory drift ratio is around 4%. Okay, you can read here what happened at this level, where the structure will exposed to significant stiffness and strength degradations, as well as the degradations in the vertical load carrying capacity. Technically, repairing work on structure may be not practical, and therefore the building is unsafe for reoccupancy because it may collapse due to strong aftershock earthquake. Okay, this is the, you can see, okay, the shear demands and the lateral deformations. Okay, this is the what I means about the interstory drift ratio. It is the relative displacement of adjacent story normalized to its story height. Okay, this is for story number 3, story number 2, and story number 1. So you can use this formula to determine the value of interstory drift ratio. Means, let's say for story number 3, you have to the displacement of, okay, let's say IDR for story number 3 is equal to displacement at 3 minus displacement at 2 divided by the story height of story number 3, and then we multiply by 100. Okay, for story number 2 equal to story number 2, displacement of story number 2 here, minus to the story number 1 divided by height of story number 2 times 100. Okay, also similar method, similar approach for story number 1. Okay, and then the displacement, we can obtain the displacement via the, maybe we can, before we construct the building, we can do the, I mean, assessment either by using the push over analysis or the nonlinear time history analysis to evaluate the maximum displacement of every story due to the lateral forces. Okay, let's see. Okay, this is the difference. Okay, this is the graph of interstory drift ratio. This is for soil type D. This is for story number 3, story number 2, and story number 1. This is the value. Okay, for let's say for soil type D, this is the value. Let's say 0.4, 0.5 something. Let's say this is 0.3 something, and this is maybe 0.2 something. Okay, this will indicate the performance level. Here, the value is still lower than 1.0. So may I know what is the performance level? What is the performance level for this building? What is the performance level? Either it's what to say, either is immediate occupancy, life safety, or collapse prevention. Any idea? What is the performance level of this building? Any idea?
Immediate occupancy.
Okay, any reason? Why? Why immediate occupancy?
Less than 1%.
Okay, because the IDR is less than 1%. Okay, good. Okay, let us try this exercise. Based on the magnitude of lateral displacement given for every story, determine the interstory drift ratio for the whole building. Sketch the distribution of interstory drift ratio along the height and determine its performance level. Okay, the distribution of interstory drift ratio is this one. Okay, this is the distribution of interstory drift ratio. Okay, the total height is H1, H2, H3 is equal, which is 3.3 meters. Okay, so we can, I advise you in exam or in the test, you must be able to answer in form of this table. Okay, you must be able to create this table, which is the number of story, lateral displacement for every story, interstory drift, and then the interstory drift ratio. It will be easier for you to determine. So we must just write down the value of displacement here. 0.314, 0.208, 0.132, and then the 0.0 for the rigid foundation. We write down here and then we calculate. Okay, use your calculator and then you can calculate. And everybody can answer this one. Displacement 3 minus displacement 2.
0.106.
Okay, 0.106. Next, displacement 2 minus displacement 1.
0.076.
0.076, where is it? Okay, 0.076, and then displacement 1 minus displacement 2 is minus displacement 0 at 0.132. Okay, and then what is the value of interstory drift ratio here? For story number 3, what is the value? Anybody?
33.76.
Okay, 33.76. 33.
No.
Are you sure?
3.21.
Okay, 3.2%. Sorry, number 2.
2.3.
2.3. Okay, good. Story number 3, number 1.
Oh,
Sorry, 4.
4.
Yes, 4.0. Okay, so this is the answer of interstory drift ratio. So how about the distribution along the height? You can see here. Okay, 4 for story number 1. This is okay. This is how you draw. You first of all you draw the scale, and then you draw the level. Okay, 0, 1. 0 to 1 is 4%. So you draw it vertically along the 4% axis. And then story number 2 is 2.3. It's around here. Okay. Story number 3 is 3.2. It's around here. So you make it like this one. Okay. So this is the distribution of interstory drift ratio along the height of the building. Means lowest story. Okay. The bottom story will experience the highest interstory drift ratio. So what is the performance level for this building?
CP. CP.
CP. CP. What stands for CP?
Collapse
Collapse.
prevention.
Yes. So it's collapse prevention. Okay, and then you have to write down what is the building condition. Maybe it at the verge of collapse. What significant stiffness and strength degradations. Maybe the repairing work is not practical, so it's better to demolish that building. Okay, you can refer back to the notes. Okay, so you can proceed to exercise number 2. For this question, you have to be careful because the story height is not similar, because this is you can see at the bottom story the story height is 4.2, and then the second one is 3.6. and then 3.3, 3.3, and 3.3. So you have to be careful for this question. Okay, so thank you so much for your attention. You can do your exercise. We will discuss later. And in the next class, we will discuss about the lateral force method, the base shear force, and the lateral force acting on every story. So thank you so much for your attention. See you in next class.